The AI stack is a layered set of infrastructure, software, and other technologies that can be deployed and scaled to meet the changing needs of AI innovators. Getting this right is essential, and here to tell us more is our brilliant panel. First, we have Nick Alprin, CEO and co-founder of Domino Data Lab, a platform for data-driven analysis. Born and raised in San Francisco, he's been in tech, finance, and has been building Domino for the past 10 years. And Vladimir Yachinovich, CEO of AlgoVerde AI, an AI platform for product development. He was one of the first to develop an AI-powered investment strategy, which he personally used. And he also played NCAA hoops. He's also affiliated with Harvard's Digital Data Design Institute, or D-Cubed. Vladimir, in order for us to understand the stack, we need to know what we're doing with it, and product design is a fascinating place to start. From your observation, how is AI accelerating the product development cycle?
Of course. So let's give you an example, and that's usually a good place to start. Behind you see a whole bunch of cars. So imagine, of course, imagine that you have to design a car. A car has 30,000 parts in it. And for every vehicle you buy today, somebody 4 years earlier had to stop and say, we have to decide what will be the features inside that car. And in case we have a customer, it's Nissan. Nissan would spend about 18 months deciding what are the features that need to go inside a given vehicle. Then they spend another 2.5 years designing it, coming up with a supply chain, and eventually the vehicle pops out at the end. If you see what they do during this period of time, they run an obstacle course. And by the way, every company, anybody in this audience that ever built a product knows that it is an obstacle course, because you go from one meeting to another meeting, another set of PowerPoint slides, and some decision gets made. Now, just for a minute, imagine that you could virtualize that process and run it in AI. Not only that you can create virtual replicas of your customers, and you can talk to them anytime you want. You can make virtual replicas of your experts. That is effectively what we did at Nissan. So we have taken a process which is about 18 months long to about 3 to 4 months, saving them a year. And now if you think about that as really innovation at scale, one thing is to give any one of us an individual productivity tool, a copilot, something you can do in ChatGPT. But the other one is to reimagine your whole process and basically save a year. That's what we did.
You make it sound so easy, but I imagine it was not. First, why was Nissan able to do this, and then how? I imagine culturally this might be hard for organizations, especially one as capital intensive as an automotive manufacturer. How did they do it?
Well, first of all, just imagine the magnitude of the decision they have to make. It's about over $1 billion. Every new product line is over $1 billion. So you can imagine they would be really, really scrupulous about making a good decision at the end of the day. We were very lucky at Nissan in 2 different ways. One is, both of them are mostly counterintuitive. The first one is, it turns out if you see the headlines, Nissan was in a huge degree of trouble, still is. So they needed help, and AI was one of the avenues they would do. They were not sitting pretty.
So they were desperate?
I would not call them desperate, but they were certainly highly motivated.
Motivated.
Highly motivated.
Good.
But there was a second ingredient, and that is a critical ingredient to all of these adoption cycles. We worked with a very talented team that was in the function that needed to solve the problem. We did not work with the AI team. We did not work with the digital transformation team. We did not, I don't think I've ever met even the CIO of Nissan. But we worked with the people that needed their job done better. And that was critical. So that is why with us. The how part, our critical claim to fame is that we have, in this audience, this would be probably a fair term, integrated development environment. We have a no-code environment in which you can create the workflows and replicas. We can also have a no-code environment which can create replicas of your customers, and then we can let you run simulations as much as you want until you come to the right decision.
Fascinating. I want to come back to no-code solutions because I think that's something that we're going to want to talk about. But Nick, what are you seeing as the primary needs emerging from your customers in terms of AI?
Yeah, well, let me maybe draw a distinction because this word AI is getting thrown a lot around to mean a lot of different things. So AI is a technology, right? It's like it's like motors. I mean, you can use it to do a bunch of different things. The distinction I want to draw is in the companies we work with, there are folks who are using tools that other people have built with AI. Software developers using coding assistants is a great example, and then there are organizations that are building their own AI-powered tools for internal use cases. And I think it's really important to draw a distinction between those two things and what each calls for. In the consuming of tools other people have built, right? The most widely adopted use cases and the ones that are seemingly having the most traction are coding assistants, and then basically flavors of better search. So I've got a bunch of internal documents. I need to find the one that has what I'm looking for, or I need it summarized in a certain way. Those kinds of things are really good for sort of pre-canned, commoditized tools. I think the much higher value use case, the much higher value, sort of the higher potential, higher impact use cases are more organizations that are saying, hey, we've got some domain-specific problem that's unique to our business. We are going to apply this technology to build our own variations of AI-powered systems or models to do something unique to what we need. So, examples there are like looking at call center logs to build very tailored views of customer sentiment and use that to drive customer success organizations, or even setting aside sort of Gen AI and LLMs, looking at use cases for image recognition to do things. I was telling Nina before we kicked off here, we work with the Navy, and what they've done is build image recognition models that they deploy onto unmanned underwater vehicles, sort of submarine drones, to be able to detect mines without risking humans going off into those submarines and potentially putting their lives at risk. We work with 10 of the largest top 20 pharmaceutical companies in the world, and some of the things they're doing with image recognition are amazing. They're able to take slides from pathology imagery from tumor slices, and through image recognition, they're able to predict certain mutations on those tumors without doing a more expensive and time-consuming DNA sequence. So they're able to target precision medicines a lot more effectively. So those are a couple of examples in the buckets. But I really want to focus on this distinction between are you using AI or are you building AI? Because each of those things call for very different stacks. And I know this panel's about the stack, so we can sort of go in either direction.
Yeah, well, yours is a data-driven platform. What role does data play in these stacks or in the products that your customers are using or building?
Sure. Well, let me clarify. So the platform we make, Domino, is a sort of end-to-end lifecycle management for building models and other AI-powered systems. So it's a workbench for data scientists to do experimentation and iteration, to deploy models and monitor them when they're in production, and for executives to oversee and manage all the work that's being done in a large data science organization. But I think it's cliche at this point to point out that obviously data is critical, and that includes both the ability to find and use the data you need. That includes the ability to control access to the data. That includes the ability to understand data quality. I'll just touch on one interesting thing that's emerging as Gen AI use cases gain more adoption. Is traditionally a lot of AI was done using structured data, and so what was important was to pull data out of your relational database systems and build models around it. The Gen AI use cases all pretty much depend on unstructured data, and what that's causing for a lot of enterprises is a friction point where a lot of their unstructured data is in much more antiquated legacy systems. It's legacy document stores, network drives that no one's really thought about the data infrastructure for in decades, and so that's creating a friction point where it's a practical issue to get some of the data you need for building say like a RAG system. Happy to go deeper, but I want to modulate the level of abstraction here.
I think we've got some interest in this. Why don't you keep going? I see.
Are we doing interactive?
Let's jump in. Grab a question. Yes. Please.
More fun.
Can you tell us your name, too? We're going to get up here.
My name is Despina. Hi, Despina. Hi. Right, since we're talking about the stack, right, so let's go a couple of layers, right, I'm peeling this onion. What bottlenecks do you see in the infrastructure? Do you have pain points with training or with inference or with both, and how do you deal with these?
In the infrastructure?
Where do you run this? Yes. First of all, if I may ask, where do you run your models?
Sure. I want to be really careful not to drift into a sales pitch. So let me talk. The platform we make runs on any infrastructure, and in fact, we run on hybrid infrastructure. And one of the really interesting trends we're seeing we work with Global 2000. We work with large enterprises, and one of the really interesting trends we're seeing is a move towards more hybrid or multi-cloud infrastructure. Right? We talk about the repatriation of cloud workloads, because over the last 15 years, everyone gradually moved to cloud. Now, what's happened with cloud in the era of AI is a couple of things. One, it's turned out it's really, really expensive. And in particular, the sort of GPU demands have caused companies to, sort of have staggering cloud bills. And so if you're doing a lot of training or now inference workloads, it can be more cost-effective to have an on-premise GPU cluster instead of doing everything with the cloud. That also gives you more control over your capacity. We've had customers who have maxed out the GPU availability that AWS would allocate them, for example, and so their research got stuck. The other thing that's going on, though, with the push to multi-cloud or hybrid cloud is, like I said earlier, a lot of the data you need for these modern AI workloads is not structured data that's been put in a Redshift database or whatever. It's legacy on-prem data that's in your network drives. And so to have AI workloads that can span across modern infrastructure but still use legacy data, sometimes you need connectivity to run those models back on-premise. Is that helpful? It's a broad. Okay. Okay. Your question is, what are the challenges of the infrastructure level?
I think she said pain points.
Because you don't work at the infrastructure, right? Your experience is at the software side, at the application level.
Mm-hmm.
So do you think that your application would be faster or would train faster and effectively it would be cheaper if there's something better that you could do at the infrastructure layer, and what it is? What is that?
Well.
Yes. All right.
Are there opportunities to improve performance at the infrastructure level?
Yes. What type of pain points you have at the application level that you have spotted are attributed to the infrastructure and can be tackled there?
Right. So obviously there's sort of a selection bias here. I mean, we only know about the problems that are problems we can help with usually. So I do think that data connectivity in a world of heterogeneous data location is a big problem, where the data is not where the compute is. That's a big problem. But to answer maybe a little more directly what you're getting at, when it comes to opportunities to improve performance at the infrastructure level, the big area we're seeing investment here is in these alternative compute tools and specialized compute tools like Cerebrus systems. I don't know if you've heard of that. They're sort of saying commoditized general purpose chips, even GPUs, will never be able to get the performance you need for these very specialized workloads. So they're building chips that are designed, just to execute, say, transformers. And because of that, they can really optimize them. So if you look at Cerebrus, I forget the stats, but the rate of token generation they can do, it will just blow NVIDIA's latest hardware out of the water. So I think that's interesting. But I want to note that from what we see, very few organizations need that kind of performance. That mostly what you can get with sort of NVIDIA hardware or even using these third-party services is pretty good for most use cases, unless you're building your own next-generation LLM and need that kind of high-performance training.
I want to ask Vladimir about scaling.
Sure. So far, this discussion was looking at the supply side of the equation. How can we optimize supply and squeeze a little more out of it? What is a better combination of GPUs, the cloud, et cetera, et cetera? Let me flip this argument and look from the demand side. So when you look at it, I mentioned Nissan before. Nissan really does not care about everything we have just talked about. What they care about is getting answers to and insights so they can make faster, better management decisions. And how does this practically impact the stack? The first one is you need to have a dynamic stack. To say that one model, you're going to just link everything to one little model, or big model for that matter, and just run everything to it. No. Every task has to be optimized for the LLM. LLM has to be optimized for the task. The second one is, how do you get into proverbial embeddings? How do you find what you want to do? Well, you need a lot of agent-related work to find which people like sunroof, which has 2 openings, which is retractable, which is not retractable. It is not a simple task. The third thing you have to accommodate is their own internal data. That's what we are touching on. But it is not to ingest everything they got. It is to ingest what is needed to solve the problem at hand. And that is where, so it is really important to start this with the end user in mind and then reverse engineer the stack for that. That is at least what we do.
So you're not going on a fishing expedition, rather you're ending where you start.
Exactly. So fundamentally, what we try to do really, really hard is to eliminate all of these headaches for our users. Users are not going to worry, I'm using Sonnet 4.1 versus Opus 4.1 versus
This point about model flexibility is really important. And again, since we're talking about the stack, there's a component that we're seeing all of our customers now build into their stack, which is some people refer to as sort of a model gateway or an LLM gateway or an AI gateway or sort of a router. I do think that's going to be a standard part of every enterprise's stacks, because no one wants to be locked into one LLM provider for cost reasons, for task specificity reasons, for security reasons. That some companies want to use third-party LLMs for certain use cases, but switch to internally hosted ones for others for more sensitive data. That's maybe one sort of very concrete takeaway is this like gateway router component is going to be a standard part of the modern AI stack.
You mentioned security. Security. How are you handling security, especially within the AI realm?
I don't mean to answer a question with a question, but that is, could you say a little more about what aspect of security?
Well, protecting IP. I would say, like you're saying, a lot of model switching. So
yeah, protecting IP.
Context.
Yeah. Yeah. Great.
He's asking about security, protecting IP, holding on to context and other private data or things proprietary.
So building off that, what I just talked about with the sort of component of the stack, the gateway. So what the gateway does is all of your requests to an LLM, instead of going directly to, say, OpenAI or Anthropic, they go through this layer. This layer then routes to one of those. And that layer in the middle, this gateway layer of indirect, we're at Google, so a famous quote in computer science is all problems in computer science can be solved with a layer of indirection. And it's a good example. So this layer of indirection is a point where you can start to do things to your initial prompt or your response that comes back. And so there's a concept in the stack called guardrails. And so there are emerging products that are for building or implementing AI guardrails. And when you define your guardrails, you can say things like, I want to scan this prompt for PII, or I want to scan my response that comes back for toxicity or something like that, or hallucination. And so this sort of you put these guardrails in place around in your AI gateway, and that's how you can start to prevent some of these things. But I'd also say, like, at an enterprise level, education and user training there's no single silver bullet to prevent these kinds of security issues. You want to take a layered approach, where you have some things like guardrails in your stack. You do a lot of user training. You still want to have granular data controls at the level of your data store. So if you're implementing a RAG use case, the user who's invoking the RAG use case can't pull data out of the systems that they don't have access to. So all sorts of things like that you layer on. It's hard.
Vladimir, what are you seeing on your end?
Well, security is really important, especially if you're designing a car which is going to be on the road 4 years from now. They don't want the rest of the world to know about it. If you actually visit one of these automakers, usually this is in the basement, big black room as big as this, full of vehicles. So they're obviously really paranoid about it. And hence, we are paranoid about it as well. So what we do, we were forced to do a single instance implementations. We cannot, what we do in a multi-tenant environment. This is not Salesforce. This is not one of these things. Every customer has its own instance, and we keep all of the data cordoned off. And we run into a really unusual problem. In order to deal with security, or who can see what they can access, you impede adoption. And that's the balancing act. You would want somebody to go, oh God, we have this new feature, look at it. And text it, Slack it, email it to their core workers. How do you control that propagation? So it is a very interesting balance. It's security you have to achieve, but it does impede adoption internally if you really do it in a very stringent way.
Vladimir, you wrote a paper called The Crowless Future, Generative AI and Creative Problem Solving. How can AI be used to identify problems to solve? Is there a sort of creative problem-solving approach, is there a sort of collaborative problem-solving approach where humans and AI together identify and solve problems?
Yes, Nina is very kind. This is one lonely research paper that I've written at Harvard Business School. So if you look me up, you will see I only have one paper to my name. But let's start with a problem. I was teaching a class at Harvard Business School, a short class on circular economy. And what we wanted to do is run a really large crowdsourcing exercise in a traditional sense. Give me a problem, give me a solution for circular economy. You know, it's very broad, and we run it globally. And we got like 238 entries after running it for about 8 or 10 weeks. Then we reproduced the same exercise in an LLM. Actually, we used at that time ChatGPT. And we came up with 250 in one afternoon. And this is one of the wonderful things about LLMs. When they fantasize, when they hallucinate, great. What is so bad about that? It can actually show you a whole bunch of new things. So we use this extensively to generate possible solutions for the problem in our platform. So we have really doubled down on this. And now you can have literally hundreds of ideas created on the fly how to solve a specific problem, and then human can be in a loop and decide which of those would have more merit and evaluate them more deeply. Just to put to give you one magic number.
So you're using it as a brainstorming tool?
If one of the steps in the workflow is, I have this problem, give me 25 ideas how to solve it, yes, that's exactly what we would use. And it does a splendid job at that. I think most of you will know that. You just have to guide it very carefully into the embeddings. Yes?
Could you expand on, you said, if it hallucinates good?
Yes. Oh, yeah. Hallucination is not a necessarily bad thing. One of our favorite steps in the process is give me 25 moonshot ideas. And moonshot ideas suggest something which is completely, really a moonshot. It is too far-fetched. However, what we have learned is it is much easier for a human to edit, curate, and delete an idea than to create an idea. Because to create an idea, the research shows, actually it was done at Harvard, Gary King's research, average human can generate 6 to 7 creative ideas a day. I give you 25, I give you 50. Now I can react to them and do something about this. So that's how we leverage it, and we love that portion.
Nick, I want to ask you if you're seeing any interesting, novel, and unexpected use cases of AI with your customers. Like this, looking at the hallucination as an opportunity to see new ideas or problem solving.
The novel ones, I think, are the ones I mentioned a few minutes ago, are some image recognition in life sciences and unmanned underwater vehicles. The Gen AI use cases I'm seeing, I'm squarely in the middle of the road in terms of my optimism about Gen AI. I do not think it is the most amazing thing in the world, but I also don't think it's all hype. There's solid use cases for Gen AI and LLMs. I think they are mostly in text generation to help with coding and in various forms of search and summarization. And so, if you're, I think call center analytics is a great example, right? Like analyze the transcripts from all my my support conversations with customers, use that to give me signals around customer satisfaction. Phenomenal use case. But I think even if you're like a law firm or something, I think hallucination is a feature in some cases, like when you're trying to generate novel ideas. The problem is it's a bug in other features where you need precision and accuracy. And so the important thing is for companies to understand what type of use case do I have? Is accuracy paramount? If it is, then I shouldn't use an LM because it's going to take me just as much time to check the LM's work as it is going to be to do the thing myself in the first place. So I'll just come back to where I started in the beginning. Like Gen AI is a technology. It's not a solution in and of itself. So it's really important to understand the parameters of the problem you have and whether that makes the technology a good solution to that problem.
I think that this theme of being able to identify your problem is a really nice way to kind of end this conversation. Vladimir, do you have a couple words about that you'd like to share?
I really do. There's this famous saying about Albert Einstein, who was once asked, this big meteor is about to hit the Earth. We have 60 minutes to solve the problem. And they asked him, what would you do? He said, I would spend 55 minutes analyzing that problem. So one of the biggest issues I see with Gen AI and so forth, that we are all incredibly impatient. And we don't spend the time to really define very specifically what do we want it to do. If you can define it really, really well what you should do and iterate on that, I think we can go much deeper into embeddings, and particularly now with reasoning models, and get to something meaningful. But focus on the problem's domain. Leave the solution domain for the second step. Don't be impatient.
Thank you. We have time for one or two questions. If anybody has one that they'd like, we can. Any brave people want to ask these two brilliant guys about the stack? Oh, I'm sorry. Okay, great. I'm going to pop over here so that we can put you on mic.
Oh, great.
Ben.
Yes, Ben. I wanted to ask, there's open weight models, and then there are the frontier models with the APIs. And do you see, because this is talking about the next wave, what percentage of folks are actually taking the open weight models, fine-tuning it themselves, augmenting it with their own data, extending the training, as opposed to just saying, I'm just going to call the APIs, I'm going to use solutions like RAG, I'm not going to worry about changing the weights on the models in any way? And do you see that as we go into the next wave, that more and more people will fall into that latter category, and open weight models really won't play that much of a role because the people aren't going to take the time and trouble to tune?
Unfortunately, the answer to your question depends on the month when you ask me the actual question. So there will be specific times when, remember I said dynamic stack? The models have to swap in and out depending on what you want to do. And you have to be comfortable with that. And it's not comfortable at all, because somebody will introduce the next version and something new will happen. So adjustment. So this tug of war will play itself out. If I was to bet, I think the open source models will eventually prevail. But in the meanwhile, it's this game of jumping from one escalator or another, one treadmill, another treadmill, and trying to keep running. That's what we do.
The orthogonal concern to, are you fine-tuning or not, is do you require privacy, such data privacy of where the model's running? So we're seeing adoption of the open source models by customers who don't want anything sent out to OpenAI or Anthropic, simply because they can run the thing in their own infrastructure, even if it's closed weights. The fine-tuning decision, I think, first of all, I think as the general purpose models get better and better, there'll be less need for fine-tuning, and so we've already seen that happen. Remember, 2 years ago, everyone was talking about sort of building their own, and then we had fine-tuning, and now we're not even really talking. Then it just became RAG, right? And then some are speculating that as the models get even better, you won't even need RAG anymore. I don't buy that, but anyway, I think there's still fine-tuning in highly specialized domains, like a pharmaceutical organization trying to adapt one of these things to do molecule design or something like that.
Okay, we're going to have to leave it there. To be continued. You can find both of these very smart people outside if you want to ask them one-on-one. Otherwise, thank you very much for joining us. And thank you both for your expertise.